Welcome. Today we're taking a deep dive into artificial intelligence, specifically looking at it through the lens of modern science.
Right.
We've gone through a lot of the research to pull out the key facts, what scientists are really finding out about AI right now.
Exactly. It's about understanding AI not as some sci-fi concept, but as a serious field of scientific study.
So the idea is to give you a clear, kind of insightful overview of where science stands on AI today.
Think of it as a shortcut, really, to the core scientific ideas driving AI.
Okay, so let's unpack the first big idea. Fundamentally, modern science tells us AI's power stems from algorithms.
Those step-by-step computer instructions.
Right, instructions processing just massive amounts of data.
Huge amounts. And it's all about finding patterns in that data, really, using those patterns to make predictions or, decisions.
So it's definitely not magic.
No. It's sophisticated computation number crunching, essentially. But it lets AI spot connections that, frankly, we humans might just overlook.
And what's really amazing there, I think, is how this data-driven approach lets AI systems actually learn.
Yes. And improve, importantly, without us having to manually code every single possibility.
That seems key.
It is. This ability to learn from data, that's what's behind the breakthroughs we see in, say, image recognition.
Where computers can identify objects and pictures now. Really accurately.
Yeah, remarkably so. Or natural language processing. How computers are getting so much better at understanding and using human language.
Okay, so building on that, where does the research get really interesting now? I hear a lot about making AI less of a black box.
Yes, interpretability. That's a huge focus now.
Because early AI could be accurate, right? But you often couldn't tell why it reached a conclusion.
Precisely. And that's a problem, especially in high-stakes areas like medical diagnosis or financial risk assessment.
You need to trust it.
You have to trust it, and you need accountability. So a major scientific effort is developing ways to sort of pry open those black boxes.
You'll understand the reasoning.
Exactly. To see how the AI actually gets to its conclusions, it's absolutely vital if we're going to deploy AI responsibly.
So how is this scientific understanding translating into, real-world applications?
Well, modern science is really highlighting AI's potential to revolutionize loads of fields. Take drug discovery, for instance.
All right.
AI can sift through enormous biological data sets much faster than traditional methods to identify potential new medicines.
Wow, much faster.
Significantly faster. Or think about climate science. AI is helping us model incredibly complex environmental systems.
And maybe predict future changes more accurately.
With greater precision, yes. It's really about viewing AI as this powerful new tool for discovery, for solving problems.
It's not just about automation.
No, not at all. It's really about augmenting our own intelligence, helping us tackle challenges that were just, too big or complex before.
Right. Now, every scientific field has its big challenges, its frontiers. For AI, is that general intelligence, AGI?
That's definitely one of the major open questions, yes. Creating an AI with human-like intelligence that isn't just narrow.
But can learn and apply knowledge across many different tasks.
Exactly. And this pushes us towards a really fundamental scientific question. What even is intelligence?
Defining it is the hard part.
It is. What are the core components of human-level cognition? And crucially, how could we replicate those in a machine? We've made huge leaps in narrow AI.
Systems good at one specific thing.
Right. But achieving true, flexible, general AI, that remains a really significant scientific hurdle.
Okay, so let's quickly recap the scientific view then. AI is fundamentally about computation driven by data.
Lots of data.
And with a bit of a little push now towards making those computations understandable, interpretable.
Yeah, opening the black box.
And this is unlocking huge potential across science and beyond.
Definitely.
But that ultimate goal of a truly general intelligence is still, a complex puzzle being worked on.
It is. And this whole scientific journey, it really forces us, I think, to reflect deeply on intelligence itself, what it means, both for machines and, for us.
That's a really powerful thought to leave things on. What does it actually mean for anything to be intelligent? And how is our scientific grasp of AI changing that very definition for you to consider? Thanks for joining us on this deep dive.